Hello friends, this video on Binomial Theorem Part 7 is brought to you by examfear.com. No more fear from exam. Before watching this video, you should have watched Binomial Theorem Part 1 to Part 6. Let's take one example that is a little difficult. So we have to expand this x square plus 4x to the power 7. So we'll do this. So this we can say this is nothing but sigma of r from 0 to 7 because n is equal to 7 CR, correct, and we'll say x square to the power n, x square to the power r into, we have 4 by x to the power n minus r. We can also say x square to the power n minus r into 4 by x to the power r. But let's take this r to the power n minus r. Sum is also n. R plus n minus r is equal to n. This is the expansion of this. So now let's do the actual expansion. We'll say r is equal to 0. So we get 7c0 into x square to the power 0 because r is equal to 0. X square to the power 0 into 4 by x to the power n minus 0, that is n is here 7, so I'll put 7 plus 7c1 x square will increase the value 0 to 1 and will decrease the value of 7 by 1, that is becomes 6. Also 7 minus r is equal to 1, this becomes 6 plus, now r is equal to 2, 7c2 x square to the power 2 because r is 2 plus 4 by x, 7 minus 2 is equal to 5 plus 7c3 x square to the base 3 into 4 by x to the power 4 because 7 minus 3 is equal to 4 plus 7c4 into x square to the power 4 into 4 by x to the power, because this is 4, 7 minus 4 is equal to 3 plus 7c5 x square to the power 5, x square to the power r is equal to 5 into 4 by x to the power 7 minus 5, that is 2, 7c6 x square to the power 6 into 4 by x to the power 7 minus 6 equal to 1 plus 7c7 x square to the power 7. This is the total expansion of this. We'll now write this. So what we get is this is equal to 7c naught. 7c naught is equal to 1. X square to the power 0 is equal to 1. So we get 4 by x to the power 7 plus 7c1 is equal to 7 into x square into 4 by 6 x to the power 6 plus 7c2 is equal to 21. We solve this, we get 21 into x to the power 4 into 4 to the power 5 by x to the power 5 plus 7c3 is equal to 35 into x to the power 6 into 4 to the power 4 by x to the power 4. Please note that 7c3 is equal to 35. We have learned this combination chapter. 7c4 also becomes 35. So we say 35 into x to the power 7c4. This becomes 8 into 4 to the power 3 by x cube plus 7c5, this term will take 7c5 21 x to the power 10 x square to the power 5 into 4 to the power 2 by x to the power 2 plus 7 into x square to the power 6, that becomes x to the power 12 into 4 by into x to the power 8 plus this becomes 7 into 4 into x to the power 11 plus x to the power 14. So if you see, the power is increasing by 3, x to the power minus 7, because if you move it up, x to the power minus 4, x to the power minus 1, this becomes x to the power 2, 2 plus 3 is 5, x to the power 5, this becomes to the power 5 plus 3 8, this becomes 11, this becomes 14. So this is the answer for x square plus 4x by 7. If you expand this, so you get this as the answer. So we have one more example where we have to think a little bit. We are asked to find 98 to the power 5. What we can do? We have been told that we know the formula of a plus b to the power n, or a minus b to the power n. So we know all this formula, but we don't know 98 to the power 5. So we can also say 98 is equal to 100 minus 2, and 98 to the power 5 is equal to 100 minus 2 to the power 5. And now using our binomial theorem, we can solve this. So let's say 98 to the power 5 is equal to 100 minus 2 to the power 5. So to expand this, we'll get this summation. R is equal to 0 to 5. 5CR. We'll take 100 first. 100 to the power R into minus 2 to the power 5 minus R. So this is the formula we get for NCR expansion. Correct? So now let's solve this. So this becomes R is equal to 0. 5C0. 100 to the power 0 is equal to again 0 into minus 2 to the power 5 plus 5C1 into 100 to the power 1 and minus 2 to the power 4 plus 5C2 100 to the power 2 into minus 2 to the power 3 plus 5C3 100 to the power 3 into minus 2 to the power, this guy will decrease, 2 plus 5C4 into 100 to the power 4 into minus 2 to the power 1 plus 5C5 into 100 to the power 5 into minus 2 to the power 0. This is the expansion. So expand this, you get 5C0 is equal to 1 into 2 to the power 5 minus 2 to the power 5 is equal to minus 32 actually. So we will say minus 32, and then 5C1 is equal to 5 into 100 into minus 2 to the power 4 is equal to 16 plus 5C2 is equal to, let's find out this here, we have done in combination. 5C2 is equal to 5 permutation by 3 permutation into 2 permutation is equal to 5 into 4 into 3 permutation by 3 permutation into 2, and this is gone, this is 2 equal to 10. So 5C2 is equal to 10. So we will say 10 into 100 square, that is 100 into 100 into minus 2 whole cube is equal to minus 8, this becomes 8, I'll put minus here, minus 8 plus 5C3 also becomes same, that is 10 into, this is 100 cube into minus 2 whole square is equal to 4 plus 5C4 is equal to 1 into 100 to the power 4, 2, 2, 3, 4 into 2 to the power 1 into 2 minus 1, so we'll say minus here, and plus we say 5C5 is equal to 1, 10 to the power 5 is equal to 3, 4, 5 times into 2, 0 into minus 2 to the power 0 is equal to 1. So you got this. So if you solve this, what you get is 90392079. This is the answer. So what we have done, so we have converted 98 to the power 5 into 100 minus 2 to the power 5. We have applied the binomial theorem and expanded this to get the answer. Let's take one more example where we have to think a little more. So we are asked to tell which one is greater, this or this. So finding this power is difficult, so we can use the power of binomial. We can also write 1.01 is equal to 1 plus 0.01 to the power 1, 2, 3, 4, 5, 6 times 0. Now we can expand this. Expand this, what we'll say is this guy is nothing but 1, 2, 3, 4, 5, 6, 0 C naught into 1 to the power 1, 2, 3, 4, 5, 6 into 0.01 to the power 0 plus this time 6 times this C1 into 1 to the power 9. So subtract this 1, 2, 3, 4, 5, 6, 3, 6, 7, 3, 6, 1 is extra. So remove this till this, remove this, this is not there, into 0.01 to the power 1 plus blah blah blah. When you solve this, 100 C0 is equal to 1 into 1 to the power this is equal to 1 into 0.01 plus this C1, this itself becomes this much 1, 2, 4, 6 into 1 to the power this is equal to 1 into 0.01 to the power 1 is equal to 1 by 100 plus again some constant, we'll say constant. This also we'll assume as a constant, so this by this cancel. So this becomes 10,000 plus some constant. So that means this is always greater than 10,000. So when we are supposed to compare this and this, so obviously this is greater because we have proved that 1.01 to the power 6 times this is nothing but 10,000 plus some constant. So when you ask this or this 10,000, which one is greater? Obviously this is greater because this is equal to this plus some constant. So we'll say that this one is greater. So what we have done? We have written 1.01 to the power n in the form of 1 plus 1.01 to the power n. We expanded this and we found that this is nothing but 10,000 plus constant. That is, this number is greater than 10,000. Thank you. Visit examfear.com to watch free educational videos, try free online test, get the best quality study material, study from the best tutor and mentors, and much more. Thanks once again.